piecewise functions are a bunch of functions pieced together into one big function. Okay, so you can look on this particular graph that I found online. How many pieces of a function does it have? 3. There's 3 separate pieced functions. Yes. They each have their own area, though. They can't overlap, because as soon as you overlap, then you don't have a function anymore, right? So they have to stay in their own location. So the red function, what is that as a parent function? What function do we represent there?
Y equals 0.
Y equals 0. It's just constant, right? This is a constant. The blue part is just part of a what function? Part of a quadratic, a parabola. And the green one is just part of a line, linear function. Okay? So then they tell you in what neighborhood, what domain that particular piece exists. The red one has got to stay between -5 and -2. It includes -5, it does not include -2. Okay? The blue function exists only between -2 and 1, including both of those endpoints. And the green function includes the 5 but not the 1, so it's got to stay there. Okay? So if I asked you what is f of 2, if I wanted you to evaluate f of 2, which neighborhood does he belong to? The red, the blue, or the green? Green, because 2 is between 1 and 5. So if you were to evaluate that, you would say, I'm going to put it into this function and get 1. What about f of -3? Which neighborhood does he live in? Red. So we would put, there's nothing to plug in. He's just 0. And if I wanted to evaluate f of 1, which neighborhood is he in? Blue? Could it be green? They both have a 1. Where does 1 actually live, though? Blue. Okay, so you have to be real careful as where you have that or equal to part. So he lives in the blue. So equals 3. So that's how you would evaluate using step or a piecewise function. And they're not written this way, by the way. Normally, there's only one y equals, and then you kind of put it, those little guys, inside a big bracket. Okay, curly Q bracket. All right, so let's see if we can take this and write the piecewise function. These are parent functions. They have not been translated or moved around, so they're just going to be parent functions. Okay, so how many functions do I have within this piecewise? 3. So we're going to put our f of x or y equals outside, big curly Q. So what is the furthest left? What is that function? It's a piece of a quadratic. So again, it's the parent function, so it's just going to be the x squared. What's his domain? He lives between, what's the furthest left he goes? -infinity, which we won't write. And then the furthest right he goes is 1. Does he include 1? Yes. Okay. The middle function is a constant at what? So it would be y equals just 3, because he's constant. Remember, that's just a number. His neighborhood is between what and what? 1 and 2. And he includes 2. Right? Okay. And the last one is just a linear function. And x is between 2, doesn't include 2, and infinity, so I can erase that side. Does that make sense? We have 3 separate neighborhoods. They cannot cross in each other's. All right, easy enough. Now, how do we graph them? So, here is an example. Look at this example. So this point, this x value that is listed in both domains, it shows where the fence is, the property line, if you will, between the neighborhoods. Only one of the guys can own the fence. So who owns this particular fence at 1? Which function? The top one, the bottom one? The bottom one, right? Because it says or equal to. So this guy has to stay left of the fence because he's less than 1. The purple guy has to stay right of the fence And he lives on, and he can be on the fence. He can sit, turn down his fence if he wants. It's his fence. Okay? All right. So when we write our table of values, we want to include the fence. We want to include that number twice. Okay? Even though one guy owns the fence, we want to know where the other guy can go up to without touching the fence. We want to see where that open circle would exist. Okay? If you notice here, this was the fence. So you should see an open circle on the fence and then a closed circle somewhere else. All right. So I'm picking numbers less than 1. So if I put -2 into that top function, I get 0. If I put 0, I get 2. If I put 1, I get 3. So I'm just going to graph the left side first using those points. So I have an open circle on my fence, and then it continues forever, because it just says less than 1, doesn't say in between 2. So you want to include that line going on past that with an arrow. Okay? On the other side, the purple guy, he's going to start at 1 and 0. 2 gives me a 1. 3 gives me a 4. And then I would graph those points. Know it's a parabola, so you have to have some sort of little curve there. And make sure you show the fence guy. He's on the fence. Closed circle. So open circle for the guy who doesn't own the fence. Closed circle for the guy who does. And sometimes, if they're good friends, the filled circle and the open circle will be together. Okay? Technically still not sharing the fence, but they're buddies. All right? Does that make sense? You're going to graph each function separately within its own little domain. Right, so you try the one that's on your paper. We're going to kind of do a little question first. Where's the fence? Where is the fence located? 1. So that's the first thing I would do, is I would do like a little dotted line where the fence is. That's not an asymptote. We're just showing where the fence is. Who owns the fence? The bottom guy. Okay? So you're going to make a table. You already have a table, but make sure you kind of mark where the fence is. And that fence number has to be in there twice. I'm going to put the 1 first, before and after the fence. And then the other values you just have to pick from that domain. Your choice. I'm going to be obvious and pick these and these. And then just kind of evaluate on your own there, and you can look up here when you get stuck or when you're done to check it. Okay, so the left side does not own the fence. We're going to have an open circle there. It's a problem. Make sure you have enough points. If you want to add another point to get that curve a little more exact, you can. The right side's the line. He owns the fence, so there's going to be a solid circle on the line. We good? All right, try the next one. Now keep in mind, you can make your chart any x and y that you want. You just have to make sure you're including the fence x in both sets. So if I'm taking the square root of x, would it make sense to put a 3 in there? Do you know what the square root of 3 is? No? Without a calculator? So go ahead and use perfect squares for this bottom guy. So I would use 0, 1, 4, 9. Use x values that make sense to you to evaluate. Okay? The top's just a absolute value, so it doesn't matter what you put in there. Okay, and again, look up when you're done. Check, make sure you're where I am. You okay? The top guy owns the fence today, right? But are they good buddies? Yeah, because the other guy's hanging out with him at the same place on the fence, okay? So this is a continuous function. There's no break in it. All right, there's a break if that fence number doesn't equal, but here, the y's are the same, so there's no break. Okay. Are we comfortable that we can graph these? Evaluate them, write them. Okay, there's a couple questions on Math Excel that we're going to go over real quick, just so you're, I'm just going to kind of tell you what you have to do, because I know you can do it. How many sections do we have in this particular graph? 3, okay? You've got 2 lines and 1 constant piece, right? You have to write the equation for this line. This is not a parent function linear. It's not just going to be x or negative x. This guy you have to write the equation for. And then the middle one's obviously y equals 2. So all you have to do is find the equations of those lines. Okay? Notice in this middle guy, that 0.22, who owns the fence there? The guy on the left or the guy on the right? Can you tell by looking at a graph where they're sharing the point? You can't tell. On Math Excel, it's going to give you the domain inequality things, and you're going to fill in the numbers, so you'll be able to tell where they want you to put what, okay? The other one is this question. They're saying the piecewise function will have a break at x equals 3, except for a certain a value. When these guys are equal, there's no break. So they want you to figure out which a value would allow these two to be equal. Okay? Do we know what x is? They told us x equals 3. So we're going to plug in that part, and then it's a really easy question because they're just asking you to solve for a. So if you get one like this, understand they're wanting you to set the pieces together equal, and then fill in the x, the fence number, and then see which one you would get. Okay? All right. So